Hello everyone and welcome to this session on percentages. In this video we will see some basic concepts of percentages. Then we will see what is percentage change and percentage point change and what is the difference between the two. Then we will see some percentage equivalent of some standard ratios, and then finally we will understand two important concepts, that is successive percentage change and reverse percentage change. So let us begin. So what is percentages? Percentages, as we know, is the value out of 100. Suppose for example, if you have scored 14 marks out of 20 in a subject. So if you want to calculate what is your percentage marks, what you are simply doing is you are trying to calculate your marks out of 100. So for that we will use the simple unitary method, that is, if you have scored 14 out of 20, so what will be your marks out of 100? What we do is cross multiply the two and we will obtain a percentage marks. So 100 into 14 divided by 20, which will give us 25 is 14 into 5, that will be 70. That means you have scored 70 percentage marks. So percentages simply means what is your value out of 100. While calculating percentage, the first question that should come into your mind is what is the base with respect to which what you have to calculate your percentage. As in this example, your base was 20, which is your total marks. Similarly, in profit and loss, while calculating percentage profit, as we know, the formula is profit upon cost price into 100. So here in this case the base will be cost price. So whenever you want to calculate percentage of a quantity or something, the first question that should come to your mind is what is your base. Let us now understand what is percentage change and percentage point change. Suppose there is a company which in the year 2014 purchased a product which is costing 100 rupees. So 100 is the cost price, and then sold it for 120 rupees, where 120 is their selling price, and they made a profit of 20 rupees. So here the percentage profit in this case will be profit upon cost price into 100, which will ultimately come out to be 20%. Then say in the next year 2015, they again purchased a product which is costing 100 rupees, and this time they sold it at 150 rupees. Therefore the profit will be 50 rupees. If we calculate the percentage profit with the same formula, it will be 50 upon 100 into 100, which will give us the value 50%. So here in the year 2014, the value of profit, percentage profit, was 20%, and then in the year 2015 it has become 50%. So if you want to calculate what is your percentage point change in percentage profit, percentage point change in your percentage profit, so it will simply be the arithmetic difference between the two percentages, that is, it will be 50 minus 20, which will be 30%. So here the 30% represents the percentage point change in your percentage profit. So if you want to calculate what is the percentage change in the value of profit, percentage change in profit value. In any quantity, the basic formula for this is percentage change is given by final value minus the initial value upon the initial value into 100. Here the base will always be your initial value. This formula can also be written as final value upon initial value minus 1 into 100. You can use any of these two formula as per your convenience. In this case we will use the first formula. So if you want to find the percentage change in profit value, it will be given by final value, which is 50 in our case, minus the initial value, which was 20, divided by initial value, which is again 20, and then we'll multiply it by 100 to get the percentage. So this will be 30 upon 20, which will be 1.5 into 100, which is 150%. So the percentage change in your profit value is 150, and the percentage point change is nothing but the arithmetic difference between the two values of your percentage profits. In this way you can calculate your percentage point change and percentage change in value. You just remember this formula of percentage change in profit value. It is a very important formula and a very basic one which you are expected to remember. We will be using this formula extensively in a lot of our calculations. So now moving ahead, we will see some standard values of ratio and their percentage equivalent. As we know, the ratio 1 by 2, this is half, that is 0.5. If we multiply this by 100, we will get the percentage equivalent, which is 50. Similarly, 1 by 3, as we know, is 0.33. If you multiply it by 100, we will get the percentage equivalent, 33.33. In this way, you can calculate the percentage equivalent of all these 15 standard ratios. These values, if you are able to remember, you will be able to solve the problems very quickly. So the question now arises, how do we remember these values? The first 5 values, if you will see, are very standard basic values, which I don't think so you will be facing much problem in remembering them. 1 by 1 is 100%, 1 by 2 50%, 1 by 3 33.33%, 1 by 4 25%, 1 by 5 20%. Now let us see how to remember these values. 1 by 6. Now 1 by 6, as you can see here, is 6 and the percentage value is 16.666. So just keep in your mind that it is something which is less than 20 and it composed of 666, which is, this way you can remember this value of 1 by 6. Now we will pair up certain values and see how do we remember them. If you take 1 by 7 and 1 by 14. So first, how do we remember the value 1 by 7? 1 by 7, if you multiply 7 by 2, you will get 14. If you multiply 7 by 4, you will get 28. So in this way, you can remember this value also of 1 by 7, which is 14.28. Now to get the value of 1 by 14, all you have to do is divide the value of 1 by 7 with 2. So if you divide 14.28 by 2, you will get 7.14. In this way, you can remember the value of 1 by 14 as well. Now let us take two more pairs, that is 1 by 8 and 1 by 12. If you see 1 by 8, the value is 12.50 and 1 by 12, the value is 8.33. If you notice, in 1 by 8, the percentage value is starting with 12 and in 1 by 12, the percentage value is starting with 8. So in this way, you can try to remember these two values as well. Now last one more pair, that is 1 by 9 and 1 by 11. If you see this pair, in 1 by 9 the value is starting with 11 and in 1 by 11 the value is starting with 9. So in this way you can remember these values as well. 1 by 10 is fairly easy to remember, simply 10%. Only value that I think you will be facing problem in remembering is this one, 1 by 13, which is like a certain odd value, which I think you will be able to remember this as well, 7.69. And 1 by 15 is again simply 6.666. This is a very important table from the point of view of calculations. If you are able to remember these values, you save a lot of time in calculations. We will see in the further videos how you are going to apply these tables. So now moving ahead, we will see what is successive percentage change. So what is successive percentage change? Let us understand with an example. Rahul's salary increases by 20% in the year 2014 and in the year 2015 it again increases by 30%. What we have been asked to find is the net percentage increase in his salary from year 2014 to 2015. So it has increased by 20% and then again it has increased by 30%. So let us assume his initial salary was 100. This is a standard procedure which you can adopt for similar sums. So let us assume his initial salary is 100. Now first it has increased by 20%. 20% increase. So 20% of 100, which will be 20. So if we add this 20 to 100, what we will get is 120. Now 120 represents his salary after the increase of 20% in the year 2014. Now what we have been given further is that in the year 2015 it has further increased by 30%. So further increase of 30%. So 30% of what? 120. So if you find 30% of 120, it will be 36. So you will have to add this 36 to 120, we will get 156. So now 156 is his salary at the end of 2015. If you want to calculate what is the net percentage increase in his salary, all you have to do is subtract 156 and subtract 100 from 156, that is final value minus the initial value. This will be 156 minus 100. This will give us the percentage increase in his salary. So it is this simple. It is very simple. Now, suppose for example, if you want to take it forward, let's say in the year 2016, his salary reduced by 10%, or 10% reduction in the year 2016. So how do we calculate this? So a 10% reduction will represent 10% of 156, which is 15.6. So if we subtract 15.6 from 156, what we will get is 141.4. So now in the year 2016, if you want to calculate what is the net percentage increase in his salary from 2014 to 2016, it will be 41.4%. So in this way, you can apply the concept of successive percentage change and come to your answer. Now, one thing which is important to note here is it does not matter in which order you apply these successive percentage changes. What I mean to say is, if you have calculated first, say 30% increase on 100, 30% increase on 100, it would have come out to be 130. Now, if you find out 20% of 120 or 130, which will be 26. So the final value you are going to get is 156, which is same as above. So in successive percentage change, it does not matter the order in which you are applying the percentage change. You can apply 20% first or 30% first. You will get the same answer. So this is about successive percentage change. Let us take one more example. In this example, a shopkeeper has marked up his price by 50%, but he gave a discount of 20% to a regular customer. Find his net profit. So let us say his initial price was 100 rupees. So now he has marked up his price by 50%. 50%, which will come out to be 50 only. So now his price will be 150. But he is giving a discount of 20% to a regular customer. So he is now giving a discount of 20%. So we will subtract 20% of 150 from this, which will be 30. If we subtract 30 from 150, we will get 120. So now this is his final price. So what will be his percentage profit? Final value minus initial value upon initial value into 100. You can apply that formula, or you can simply subtract 100 from the final value. You will get the same answer, which is 20%. So here the percentage profit is 20%. So this was all about successive percentage change. Now we will move on to our next concept of reverse percentage change. Now first, to understand what is reverse percentage change, we'll take this simple equation. Speed, which is equal to distance upon time. Now we'll consider two conditions. The number one, when distance remain constant, and number two, when time remain constant. Okay, so let us first consider the case when time remains constant. So in this case, speed will be directly proportional to distance. That means if your speed increases by 10%, your distance covered will also increase by 10%. If your speed decreases by 10%, your distance covered will also decrease by 10%, because it is directly related. If your speed becomes twice, your distance covered will also become twice. So the direct proportionality, whenever there is a direct relation between two variables, your job is easy. Whatever is the change in the first variable, similar change will occur in the second variable. But what happens in case of indirect proportionality? When distance remains constant, speed will be inversely proportional to time. So if your speed increases by 10%, will your time decrease by 10%? No, your time will decrease for sure, because they are inversely proportional. If speed is increasing, your time will decrease. But will it decrease by 10%? No. Why does this happen? Because they are inversely proportional. If we see the ratio form, S2 by S1 will be equal to, let's say, S1 by S2. S1 by S2 will be equal to T2 by T1, because of inverse proportionality. Now your speed has become 10% of its initial value, so it will become 1.1 times S1. From this we will get T2 by T1 as 1 upon 1.1, which can be written as 10 upon 11. So you're now the ratio T2 by T1 is 10 by 11. If you want to calculate what is the percentage change in time, what we'll do is use the formula final value upon initial value minus 1 into 100. We are using the second form, which will be T2 by T1. Now T2 by T1 is 10 by 11 minus 1 into 100, which will come out to be minus 1 by 11 into 100. From the ratio, from the table of percentage equivalent of the ratio, we know the value of 100 by 11 or 1 by 11 is 9.09% with a minus sign. The minus sign indicates that the time is reducing. By how much percent it is reducing? It is reducing by 9.09% and not by 10%, as was in the case of direct proportionality. In direct proportionality, whatever is the change in the first variable, similar change will take place in the second variable. But in case of inverse proportionality, it is not so direct. We will have to do some calculations. So from the exam point of view, if you will see, this is too much of a calculation. You don't have this much amount of time to go through such a calculation, apply this formula, then calculate the value. What I am going to show you is a very simple method by which you can simply calculate this value within 10 seconds. So in this case, what has happened? Let's see that. Speed has increased by 10%. So in ratio form, what is the value of 10%? It is 1 by 10. Now since the speed is increasing, what we will do is we will increase the denominator by 1. So we will get 1 by 11. This 1 by 11 represents the percentage change in time. Percentage change in time. Because speed and time are inversely proportional, speed is increasing, therefore time will decrease. By how much percent it will decrease? It will decrease by 1 by 11%, which is 9.09%. See, we can get this answer within 10 seconds. You don't have to even do this much of calculation also. You can do this entire calculation mentally if you remember that table of percentage equivalent of ratio. So how do we standardize this procedure? Suppose if there is an X percentage increase in A, X percentage increase in A, it will result into 1 upon A plus 1 percentage decrease in B. So what is A here? What you have to do is represent this percentage in ratio form. Suppose for example, if there is a 25% increase in some quantity, say A, so in ratio form what this 25% will be? It will be 1 by 4. So this will be your value of A. 1 by 4 will be your value of A. So you simply substitute 4 here, we'll get 1 by 5. So B will decrease by 1 by 5%, which is 20%. So if A is increasing, B will decrease. Because here we have increased, that's why we are adding 1 to the denominator. Let's see what happens when A decreases. Let's say if there is an X percentage decrease in A, it will result into 1 upon A minus 1% increase in B. So if A is decreasing, B will increase. Because it is decrease here, that's why we'll subtract 1 from here. It was increase here, we have added 1 here. It is decreasing, that's why we have subtracted 1 from here. Suppose for example, if there is 10% decrease in A, if there is a 10% decrease in A, in ratio form it can be written as 1 by 10. So this will be your 10 will be your value of A. If we substitute 10 here, 10 minus 1, it will be 1 by 9. So your B will increase by 1 by 9%, which will be 11.11%. So this is a very important concept from the point of view of exam. If you are able to understand this concept of reverse percentage change, you can avoid this much of calculation and you can arrive at your answer within 10 seconds. All you need is a little bit of practice, and then you will not have to even do this much of calculation also. You can very easily do this calculation in your mind. Let us take a few examples and understand it better. In this example, if the cost price of an item increases by 50%, so here we have an increase of 50%. By how much should the consumption be reduced so that the total expenditure remains constant? Now what is total expenditure? Total expenditure is nothing but cost price per item into number of items that you are purchasing. Okay. Now if you want to keep your total expenditure constant, so the cost price will now be inversely proportional to your consumption. So if your cost price is increasing, your consumption will have to reduce. So the question is, by how much percentage should your expenditure be reduced? Now your cost price is increasing by 50%. 50% in ratio form is nothing but 1 by 2. Since it is increasing, what we will do is we will increase the denominator by 1. We will get 1 by 3. Your consumption will reduce by 1 by 3%, which is 33.33%. So in order to keep your total expenditure constant, and if your cost price is increasing by 50%, you will have to reduce your consumption by 33.33%. If you want to go with the long method, it will take at least 2 minutes to solve this example. But if you have understood the above concept, you can do it within 10 seconds. Let us see one more example. In this example, A's salary is 10% more than B's salary. By how much is B's salary less than A's? So you might see that this sum is a little bit different, because in place of increase we have the word more, and in place of decrease or reduce we have the word less. It does not make any sense, because you can see increase is positive in tone, same as more. More is also a have a positive connotation to its tone. Okay, so whatever is applicable to increase, you can apply the same concept to more also. Let's see how to solve this one. A salary is 10% more, so 10% in ratio form is nothing but 1 by 10. Since it is increasing, it is more, we'll increase the denominator by 1. What we'll get is 1 by 11. So B's salary will be 1 by 11% less than that of A, which will be nothing but 9.09%. I hope you are able to get this concept of reverse percentage change. If not, then please rewatch this video. If you have any queries, you can mention them in the comment section and we will try to solve them as quickly as possible.